Welcome to the lesson on isolation fault testing. In this lesson, we will explore how to use an insulation meter to test for an isolation fault in a battery electric vehicle. Let us look at our lesson objectives. By the end of this lesson, you will be able to describe an isolation fault test and explain its critical role in ensuring safety within high-voltage systems. Next, you will be able to name the specific components that are susceptible to isolation faults. Then you will be able to name the appropriate personal protective equipment, tools and equipment needed to conduct an isolation fault test safely. Finally, you will be able to list and outline the step-by-step process for performing an isolation fault test in a BEV. High-voltage systems typically operate at around 400 volts or higher voltages, posing significant safety hazards if unintended electrical paths arise between the high-voltage components and the vehicle's chassis ground. Isolation fault testing focuses on detecting any faults that may occur between the high-voltage electrical components and the vehicle chassis or ground. This is particularly important because any such fault could potentially expose you to electric shock hazards. Isolation fault testing is typically performed during manufacturing as part of quality assurance processes and during the service or maintenance of the vehicle to ensure ongoing safety and reliability. Isolation fault testing is critically important in high-voltage systems for several reasons. BEVs operate with high-voltage systems, posing a serious electrical hazard if there is a leak to the chassis. Isolation fault testing helps identify these issues, preventing potential shocks or injuries. Isolation fault testing provides a vital tool to pinpoint the root cause of issues like power loss, decreased range, or unexpected shutdowns, leading to faster and more effective repairs. Manufacturers often have specific protocols for servicing the high-voltage system, and isolation fault testing is frequently a mandatory step. By following these guidelines, technicians can ensure their work meets manufacturer standards and avoid potential warranty complications. Components that could potentially leak high voltage are the high-voltage battery pack, the power inverter and converter, the high-voltage AC compressor, the power steering system, the electric machine or the drive motor, and the high-voltage cables and connectors. The high-voltage battery pack is the most likely source of high-voltage leakage. If the battery pack's insulation fails or if there is internal damage, it can lead to leakage into the chassis ground. The power inverter and converter convert the battery's DC voltage to AC for the motor. A malfunction or insulation breakdown can cause leakage. If the high-voltage AC compressor is present, its high-voltage system could also leak if its insulation fails. Some BEVs use high-voltage electric power steering systems. A fault here could lead to leakage. A shorted or grounded winding in the electric or drive motor itself is a potential source of leakage. Damaged or improperly installed cables and connectors can also create leakage paths. Insulation meters, also known as megometers, play a vital role in isolation fault testing as they measure electrical resistance, particularly at high voltages compared to a standard digital multimeter, DMM. The high-voltage capability allows an insulation meter to evaluate the integrity of insulation in high-voltage systems, where even small leakage currents can be dangerous. The meter can be set to various voltage levels depending on the specific component or system being tested. While a DMM can measure resistance, its voltage output is typically limited to low ranges, under 1,000 volts. This makes it unsuitable for testing high-voltage components where leakage currents are of concern. On the other hand, an insulation meter provides the high voltage necessary to simulate operating conditions and effectively detect even minor insulation weaknesses that could lead to isolation faults. In essence, the high-voltage capability of an insulation meter makes it the ideal tool for isolation fault testing, allowing technicians to identify potential safety hazards and ensure the integrity of the high-voltage system. Let us now look at the requirements to ensure you are safe. When working on high-voltage systems, so wearing appropriate personal protective equipment that includes gloves rated for 1,000 volts DC, safety glasses and face shield, flame-resistant and arc-rated clothing, and electrical hazard safety footwear are crucial to ensure the safety of technicians. Safety glasses provide eye protection against potential hazards such as electrical sparks, debris, or chemical splashes. Additionally, a face shield offers an extra layer of protection by covering the entire face, including the eyes, nose, and mouth, from any potential impact or splashes. It is essential to have a BEV-trained assistant present throughout the entire process. This technician should be familiar with the specific vehicle model, understand high-voltage system protocols, and be able to provide immediate assistance if any unexpected situations arise. The presence of a BEV-trained assistant adds an extra layer of safety and ensures prompt action in case of emergencies. These safety measures help mitigate the risks associated with working on high-voltage systems and minimize the potential for injuries. Having and using appropriate tools and equipment is essential before performing the isolation fault test. A diagnostic scan tool can be helpful in retrieving fault codes stored by the vehicle's onboard computer system, which may provide additional clues about potential isolation faults. An insulation meter applies high voltage to the vehicle's high-voltage components and measures the resulting electrical resistance. The test leads are cables that connect the insulation meter to the vehicle's high-voltage system. They are insulated to withstand high voltages and have probes or connectors on the ends for safe and secure connections. Alligator clamps provide a temporary connection between the test leads and the vehicle's high-voltage system. They are useful when probing for test points or when the tested component lacks dedicated connector points. A rescue hook allows for the safe extraction of a person who might be experiencing electrical shock from a high-voltage component. A 1,000-volt insulating mat provides a safe working surface to stand on while performing the isolation fault test. Window sucker signs can be placed on the vehicle to alert others of work being performed on a high-voltage system. Always remember to consult your manufacturer's recommendations for the components you are testing to determine the required test voltage.